It's an objectively well-known fact that nuclear science and nuclear engineering is the most interesting thing it is possible to do in the entire world. My name is Donald Wall, and I am a faculty member here at the University of Florida, and I'm the director of the University of Florida Training Reactor facility. It is the only research and training reactor in the state of Florida. This reactor began in 1959, and it was part of the Atoms for Peace program that was envisioned by President Eisenhower. You recall at this time there was a lot of nuclear weapons testing going on, and there were a lot of other people saying, wait a minute, we can do a lot of things with nuclear energy. Let's start to design reactors that we can use for research and for teaching, that are safe to use, that are designed to be safe, and will be wonderful assets for the United States in terms of educating people and providing needed materials, for example, for medical use. There's only 25 training reactors in the United States, and those are used to teach students about nuclear science and nuclear engineering, to train them to go into the field so that they're well prepared when they get there. And facilities such as this throughout the country perform research that is exceedingly important in terms of, say, medical advancements, material science, testing things that might need to go into space where there's a high radiation environment. And so there are many different types of research that are associated with these facilities. It's a really wonderful complement to the educational program, because we have a nuclear engineering program here at UF. And students go through and they learn the theory about how reactors work and how to design them. An undergraduate student, they would learn how reactors operate, how to design them, how to analyze other reactors that are operating, learn the essentials of nuclear fuel and how it's made and how it's used. They can learn how to work with radioactive materials or how to operate instruments and detectors. For the graduate students, the education is much more tailored to the individual interests of either the faculty member who is the advisor for a graduate student or the student themselves. And that's where the variety of expertise here is really valuable, because there's enough overlap so that there's complementarity, but also enough difference, and so that a student can have a wide variety of choices of different sort of areas that they want to study. Why else though? Why here? And aside from the fact that it's objectively the most interesting thing that anybody has ever done, well, there's a great need for people in the field. By and large, the workforce, the nuclear workforce, is aging, and many of the people are getting near retirement or retiring already. And so the field is now wide open for young people to go into. There's a tremendous amount of demand. And what we're really seeing now is a much increased demand for electricity to power things like server farms and AI. So there's a tremendous number of opportunities available for people going into the field. And so we are very well placed to assist students in getting the exact kind of education and experience that they need in order to step right into a very good job on the day they graduate.